equal to x cubed. The other direction from 0 to 8. So that's the x direction, y direction. That's the portion of the cubic function. That's the region that we are dealing with, as you can see. This is the region, okay? Here we go. So I formulated my integration. I will integrate with respect to do dy, blah, blah, blah. As you can see now, it's going to be x cubed, just multiplying and having the addition. That's the result of our integration, okay? Okay, very good. Once more, we want you to do this example. This example is really from the problems that was sent previously, and I believe it's really very close to ours. Now, I want you to do the region y is less than or equal to 2 of an x. Once more, y is less than or equal to 2 of an x. So if I want to draw our region, that's the x-axis, that's the y-axis. Y is equal to 2 of x, so if x is equal to 1, that's the shape of the line that we are drawing. We are talking about y is less than 2x, so I'm interested in the area under this straight line, and y is greater than or equal to 0, so it's just only the portion that's above the x-axis. And the 4x less than or equal to 1. This is the boundary, x is equal to 1. This is less than 1. That's the region that we are dealing with. Karim and Hussein, can you imagine the region that I'm talking about? I made the boundary first. Y is equal to 2x, which is this straight line. This straight line will divide the first quadrant, or the first part, into an area above the line and an area below the line. The area above the line, okay, it will have y greater than 2x. So y is greater than 2x. The area below or beneath this straight line will be for y greater than or 2x, all what's below this inclined line. And then y is greater than 0, it is looking upward. And 4x less than or equal to 1, that's my boundary, less than or equal to 1, it is this part, so it is this region only that we are interested in. So once more, I have the function y equal to a 2 of an x, I have x equal to 1, and I will need to integrate, double integration of e to the power of negative x squared with respect to dx dy. Ya Karim, can you do dx dy? No, you are not going to be able to do it. dy dx. Yes, you are right now. So it's going to be a dy, then a dx. So for this region, I will go first in the y direction. This is number 1. Then second in the x direction. If I want to go in the y direction, I will go from y is equal to 0 inside my region, till you reach y is equal to over 2 over x. In the direction of the x, it will start from 0 up to 1. Now I can integrate. Integrating with respect to dy will leave you with y. Then I will change. So it's going to be e to the power of negative x squared times y. Replace y by 2 of x minus 0, then finish up with dx from 0 to 1. So once you do this, it's going to be from 0 to 1, which is going to be a 2 of an x times e to the power of negative x squared with respect to dx. I will multiply negative and negative outside. The derivative of the power is already exists, so the integration will be negative e to the power of negative x squared. Then I will substitute by 0 and 1 and finalize my problem. These problems are really very simple, but as I told you, you will need to try them on your own. Once you try them on your own, you will discover the complexity or the steps as I told you. So once more, integrating in the direction of dy from 0 up to 2x, just substituting, multiplying the negative and negative. Now the derivative already exists, so the integration will be negative e to the power of x squared, and then making the substitution is very, very simple. The It's a very nice problem. Look to the region, please. The region is very, very simple. The region is a part of y is equal 1 over x, this curve y over x, and that's y is equal to 2, and from 1 to 2, she already gave you the graph. If you look to this area, Mr. Yusuf, Mr. Yusuf, should I integrate dx dy or dy dx?
dx dy. dy dx.
Why?
مثلا dy dx.
طب ليه واي نوت دي اكس دي واي؟ لو انا بشتغل دي اكس دي واي، بص بقى مستر يوسف، if I'm doing dx dy, that's gonna be the main direction. If I'm entering from the x direction, you will find this point which separates your entrance into how many pieces? 2 pieces. Above this point, the entrance will be x equal to 1. Below this point, the entrance will be x equal 1 over y. So the interval will have to be divided. But dy dx, let's study the case of dy dx. If I'm entering dy first, then dx is going to be one integration. In the direction of y, this is the gate. Am I right?
Yes.
The gate is y equal to 1 over x. So I will integrate from 1 over x. I'm inside the region, inside the region. What's gonna make me leave this region?
2.
The value of y is equal to 2. And that's for the direction of dy. For the dx, the region starts from 1
1 to 2.
to 2. I don't care about the integrand. The integrand is x times y to the power of negative 2. That's the integrand. So it's very, very simple. Now I start integrating dy, which will make y to the power of negative 2 to be y to the power of negative 1 divided by negative 1. Then I will make the substitution, replacing y by 2, then replacing y by 1 over x. Then finalizing by dx, okay, from 1 to 2 as you can see. It's very, very simple. Also, once you know how to enter the region and determine the direction, the problem is solved and you already have it as you can see. So, for this problem, you saw now, sometimes I prefer to go dy dx or dx dy according to the nature of the region, like this problem. Sometimes I will be forced to do change the order of integration because the integrand cannot be integrated in the regular order dx dy, but it's better to be it's going to be better if you change the order of integration. The volume of integration, or what we are doing, is evaluating a volume of a solid. معايا Ms. Judy? That's exactly what we are doing. You are integrating a certain function, that's the function, on a certain region. So you are getting the area or the volume under the curve. This is why once you integrate 1 dA, the value that you will have, it is actually the volume of solids of this shape that you are dealing with. So the area times 1 if we are dealing with 1. The area in general, D is a compact plane region, then the area of D can be given by, it is just integrating 1 of a dy as you can see. Here he is asking you to use the double integral, compute the area of the shadow region presented by the following figure, and he gave you this figure. He wants you to evaluate the area. Start please to tell me which direction is going to be easier on you, dy dx or dx dy. If I am moving in the x direction, this direction, so the entrance is one function, but the exit is how many functions? 2 functions. So also I will have to separate this region into 2 integrals.
So I will use
But
dy dx.
let's use dy dx. For the dy dx, the entrance for the region is 1 gate, which is this gate. And inside my region, how to go outside, it is that exit. So in the y direction, I will start from y equal to x to y equal to 2 minus x squared. That's the y direction. The whole region starts from which number to which number? From -2 up to 1. That's exactly what's happening. Now I can integrate. Integrating 1 is going to be y. Then replace y by the upper limit minus the lower limit. 2 minus x squared minus x. Then finalize by integrating in the x direction. From 1 first minus, substitute by -2, you will have the value which is 9/2 as you can see. معايا يا شباب? It's really very simple as you can see. Also, that's another problem. He wants you to evaluate y is less than or equal root of x, and y is less than 2 minus x, and y is greater than or equal to 0. If you look to the region, I need you to understand how to draw the region, because Miss Judy, if you didn't draw the region, you're not going to be able to find or to determine which direction you will use. So for the first thing, it's going to be y equal to root of an x, which leads to x is equal to y squared. So if you look to this parabola, it is symmetric about on y. This is y is equal to root of an x. This is y equal to root of an x. Okay, I'm interested in the part where y is less than root of x. In this region, this curve, okay, this curve, divide this space into two parts, or this plan into two parts. In this part, y is greater than root of x. In that part, y is less than root of x. I'm talking about this area. And y is equal to 2 minus x. So I need to draw y equal to 2 minus x. If you put x equal to 0, y is gonna equal to 2. If you put y is equal to 2, then x is gonna equal to 2, and that's the region that we are talking about. Okay, between the curve and the line and the area. Now I have a question. Which is gonna be better for you?
Yes.
To go to dy dx or dx dy, the x direction? Because once you move into the x direction, in this direction, this is actually going to be the function x equal to y squared. And the exit will be this function. I will need to get x as a function of y, which means x equal 2 minus y. So the integration limits will be starting from x equal to y squared, and the ending up was 2 minus y. That's the x direction. For the dy direction, I will start from y equal to 0 to y of this point. So I need the intersection between these two curves. How to get the intersection between two curves, Mr. Yusuf? Yes, you are correct. Substitute the equations in each other. So you will have now root of x equal to 2 minus x. Square both sides is going to be x, 2 minus x to the power of 2. Then resolve this quadratic equation. It will give you the intersection points in the x direction. معايا يا شباب? So once more, we get back to the fact that if you didn't draw the region right, you're not going to be able to speculate the numbers on the boundaries, and so it's going to be very, very difficult for you to evaluate it correctly. So once more, that's the curves as you can see. Here I prefer to do dy dx just to show you that I can separate this area, this period, into the part of the curve and the triangle as you can see. Okay, I did it and integrated, or in the x direction from y squared up to 2 minus y from 0 to 1, exactly as we did. They have of course the same results. That's another problem exactly similar to the one that we dealt with. All I have to do, but in this problem, the integrand was 1. But once you try to evaluate a volume of solid, the integrand will be the given function, which is 3 minus x squared minus y squared. But the region will be exactly the same. The region, it is from 0 to 1, which is a rectangle actually from 0 to 1, out from -1 to +1, the integration is going to be really very simple. And I believe next time, inshallah, I will give you some more problems from the sheet. By the end of this lecture, thank you very much for attending. We are ending our course for this semester, mathematical analysis. So, you have chapter 4 for the coming exam. You have 2 main chapters that's involved in the third midterm. Optimization problem, which is a huge topic. You didn't study it because you were actually focusing on, don't focus with the people outside. Be with me, okay? You were focusing on the midterm, so you didn't study them. Once more, Mr. Hussein, you are correct. Optimization problems means you have 3 situations. The optimization in unconstrained optimization. يعني ايه Mr. Karim unoptimized or unconstrained optimization? I'm optimizing a function without a constraint. So I will try to find the maximizer or minimizer of this function, and there is no constraints, there is no regulations on us. The second case that we studied is the equality constraint. So I'm actually optimizing a certain function, but under certain constraint. And in this case, we studied Lagrange system of dealing with. The last part of the optimization was a part of yesterday lecture, and we did go through the optimization of the inequality constraint. And in this case, I'm optimizing certain function, but under the condition that I have an inequality constraint or a certain regulation. Okay? This is the first part in your exam, in next exam. For the second part, it is about the double integration. What are the ideas that we try to treat with double integration? Either to get the area, which means the integrand is equal to 1, or to evaluate a volume of solid, which means I will replace 1 by the given function, and then I will do the integration. Of course, Mr. Yusab, you still have the hack of choosing dx dy or dy dx, or changing the order of integration if you need to. Okay, I can ask you about changing the order of integration, or you by yourself will decide to go dx dy or dy dx as you saw in these problems. Thank you very much, and I will continue next week, inshallah. Thank you, and wish you the best in all times.